All right, this is the brain part 2, and I'm just going to rewind a little because I was starting to cram information in to try to get it under 15 minutes. So remember we talked about the hypothalamus, and these are all of the, well, some of the many things the hypothalamus does. Remember, it's just a region here in the brain. It's not really a separate structure like the pituitary gland that really sticks out. Both hypothalamus and pituitary do a lot. They're like the two major regions in our brain that control our hormones. And the hypothalamus pretty much communicates to the pituitary gland, signaling when it should release its hormones. Note that the pituitary gland technically gets classified as part of the endocrine system, and the main distinction here is because the hypothalamus releases neurons to the pituitary gland, or releases its chemicals to the pituitary gland, but the pituitary gland releases it into the bloodstream, and that's the main requirement to be part of the endocrine system, is releasing hormones into the bloodstream. This thing called the infundibulum, that's just the stalk that the pituitary gland hangs off of here. And so notice that the hypothalamus is below, hypo meaning below, the thalamus. The thalamus is a little bit easier to see here. There's often like a spot here that they call the interthalamic adhesion, but it definitely looks a little bit round, so that's something to look for. All right, so your brain stem has your midbrain, and when we talk about the vision and hearing, there are reflex centers there because, for example, your pupillary reflex is going to send information. It's not going to send information all the way to your cerebral cortex in order for your pupils to respond. So this would be what we mean by saying that there's a reflex center here for vision. Same for hearing. This is in a structure called the corpora quadrigemina, and it's located right back in here. And in a half of brain, which this is a picture of, you only see two little bumps right here. And this picture is not real clear. I guess it's these two bumps, but I'm not sure. These just must be foldings then of the brain. Anyway, so right here and here, those are the reflex center for vision and for hearing. And it looks like four of them because when you have two sides of the brain together, you see four little bumps on the back. The best way to look for that is when you pull the cerebellum down from the cerebrum in the brain lab, you'll see them right in here. So try that. Look for those corpora quadrigemina. All right. Your pons is very easy to recognize in the brainstem because it's the roundest part of your brainstem, and so it sticks out the most, and it's going to be below your pituitary, or at least across from it. As I said before, it contains your rate and depth of breathing. Your medulla oblongata, if you remember Adam Sandler talking about that a bit in his movie, this is just a little bit wider than the rest of the spinal cord, and that's kind of how you know where it is. It's also just below the pons. It's going to control your heart rate, your blood pressure. It also helps regulate breathing with the pons. And it's involved in swallowing reflex and vomiting, so you can see your medulla is super important to maintaining a lot of functions in your body. And the reticular formation, I don't have a picture of it here, but if you hear that term, it plays a role in your awake and sleep cycles, so it can kind of help alert the brain. You may hear about it if you read about coffee studies and things like that. All right, your cerebellum. This is not a conscious part of your brain. It's a very pretty part of your brain. When you cut it in half, you'll see a really neat arrangement of gray and white matter here. But it tells you information about the position of your body parts, and this is important for coordinating your skeletal muscle activity. It helps you to kind of give accurate timing to your movements and precision to your movements. So athletes and any like musicians can appreciate this. It's also important for maintaining posture. Again, something you're not really thinking about. So again, when you look at the cross-section of the cerebellum, you'll see what looks kind of like a tree pattern. and that is the white matter leaving the cerebellum. So this is all the gray matter of the cerebellum where all the cell bodies are, and then the myelinated axons are coming out of the white matter. They call this the arbor vitae, or vitae, I guess technically in your Latin pronunciation. Arbor meaning tree, and vitae meaning life, like a vitamin, kind of gives you better, enriches your life. Or vital signs. Those are important for staying alive. So the arbor vitae is a really cool feature to look for. The smoother your cut, the prettier that arrangement's going to look. All right, some other features in the brain to look for in the brain dissection. The pineal gland kind of looks like a pine nut. If you've never seen a pine nut, it's the little tiny ones, a little bit smaller than a peanut. Kind of expensive, which is why you don't see them very often. But this gland is also an endocrine organ. It's involved in producing melatonin. You've probably heard of that over the counter. It controls your sleep-wake cycles, and so a lot of times if you're jet lagged, your doctor might prescribe melatonin to help you sleep. I took it one time in college, and it gave me the strangest dreams, so I never took it again. Your limbic system, you're going to hear about this. I think I'm going to show you a little video clip about your limbic system being your emotional brain. A lot of our memory formation happens here because it contains the hippocampus, named because it kind of looks like a, oh shoot, I thought it looked like a seahorse. It does. So for where the hippo comes in, I kind of forget. But anyway, it's located near the top of the brain stem. You don't really see it in the dissection, so I don't really bother showing you a picture of it here. You'll probably see one at some point. But it's important for long-term memory formation and emotions, as I said. All right, so let's quickly talk about concussions. This can occur with even slight trauma to the brain. We're starting to realize that they happen more often than we think. It definitely happened if a person is experiencing unconsciousness after hitting their brain, and doctors recommend watching that person for at least 24 hours to make sure that there's no intracranial hemorrhaging, meaning bleeding or pressure buildup from cerebral spinal fluid. That buildup of pressure, because your skull can't expand, could do brain damage. And so what you simply often do is kind of just wake them up periodically to check that they're alert and aware of what's going on and that there's a condition and their mental state is not declining. You certainly want to let them sleep still, so don't misinterpret that for keeping the person awake. They're absolutely going to be exhausted and they're going to need to sleep. So, something to keep in mind for first aid, but always check with your doctor and get help if something doesn't seem right. All right. Another injury to the brain that's very common is what's called a CVA, or a cerebrovascular accident. You might know of this as being called a stroke. Strokes can happen actually pretty commonly. I had a friend who had a stroke. I've had two friends actually who had, make that three. Only two people that had it since I knew them. One had it as a second grader. But it's very common for like blood clots to form in your body for various other reasons. One I'll talk to you about a little bit when we study the heart. But if that clot forms and travels to your brain, it can cause the blood supply to be shut off from that region of your brain. And depending on how big it is and what area of your brain, you're going to see certain symptoms. But almost always you'll see some kind of paralysis on one side of the body. So if like the lip is drooping a little bit, it doesn't have to be severe. It's going to be pretty subtle. So look in their face for clues. But this can be very dangerous. A lot of times it can dislodge and not do any worse damage, and a lot of times they can recover some of the injury. But a lot of times, if it was cut off for a while, those cells can be killed and you can lose certain functions. So here's just a mid-sagittal view of the brain. Just get this image in your brain. Look at the number of foldings here that you see, because you're going to be comparing this to the sheep brain in the lab, and so you want to know what you're looking for. So for example, this is your thalamus. This would be your hypothalamus, this region here. The pituitary gland has been cut off, but it'll be hanging right off here. Other things, your pons you're going to be looking for, your medulla, the spinal cord with the cerebral aqueduct down the middle of it there, your arbor vitae of your cerebellum. This is your fourth ventricle of your brain, your lateral ventricles in here, your corpus callosum, oops, and of course your different lobes. Here's the central sulcus we talked about. This is the one separating your occipital lobe. I'm not going to make you learn that one. There's the corpora quadrigemina, your pineal gland, a little bit darker coloration. So study this a little bit and get ready to look for these structures in the sheep brain. And continue working on your cranial nerves. Remember, this is what they look like. You're going to be looking for some of them in the sheep brain. They mostly go in order. 1, 2, 3. Where did 4 go? 4, 5. Oh no, there's 4. Okay, I was going to say, I didn't think it was there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so this is not the best picture. That I gave you a better picture in class, but be learning their functions and studying those. The main two you're definitely going to want to look for are the olfactory nerve, your sense of smell, because your nose is going to be right under here in a brain. And this is your optic nerve, and where your optic information, where part of it crosses over to the other side of your brain, this is called the optic chiasma. So you're going to look for that crossover. This would be like your pituitary gland, so be careful not to knock that thing off. And these are your mammillary bodies, which I have kind of cut out, I haven't talked about, but if you see those two little bumps there, they kind of look like a little pair of breasts, which is why they call them mammillary bodies, because mammals breastfeed and have breasts. So, there you have it. There's the brain, and keep on studying. One last thing, since we have time, the basal ganglia, if you're studying the parts of the brain, you see them down in here. These are what we call, remember when we said a nuclei is a collection of cell bodies in the brain? Well, this would be some cell bodies that are important in muscle movements. And these can be really deep in the cerebral hemispheres, so if you make a cross-section, I'd love to try to find some of this in our sheep brain. I don't know if they're going to be as pronounced. But these are really important for people with Parkinson's disease because these neurons are often losing their function there. So, some things to think about, some regions to study, and we're done.